Hey everyone, I'm back to do some more Sonic. Last night, what we got up to is actually last night I left it out and someone asked, "Is there a memory leak?" So my cat stood on my keyboard and scrolled across a lot, but so you know we weren't looking there before. We were actually looking at the animations at the beginning of the stage, but I mean the game is still running. I don't doesn't look like it's using up any more memory than what it was to begin with, so I don't think we have any problems with memory usage, and you can see the animations are still going. I don't think we have any massive memory leaks that are causing a problem. That was a question from chat. I wasn't sure, but I've run it for a while, and it doesn't seem to have any memory leaks, so I think we're good. So that answers that question. So today what we're going to go on with is, I've got two sprites being rendered. I've got Sonic and Tails being rendered. And a lot of the code, I've just copy and pasted it. So a lot of this code is duplicated. So the goal is to abstract away sprites and basically have sprites handle themselves. So down here I've got render sprite, which does a good chunk of work. So I've got step sprite and then render sprite. And I'm going to basically have step sprites and render sprites. So it'll render all the sprites that I want on my stage. And we'll change the sprites, update them according to logic. So that's the goal. Okay. There's one thing here actually. There's so when we load up Sonic, so you notice we're doing these slice offsets. So slice offset is a way of indexing into the ROM. So I've got my ROM file here, and I'm saying index. Take this is, I call this an offset, which is a starting and an ending of some art, or I don't know, just any content inside of the Sonic ROM. So yeah, I have the starting and the end, and then I just slice into it. I just take a slice from that ROM. And actually, there's something interesting there, which is slice offset is it's a function that works in byte string, and it's just take and drop. Turns out those get optimized so that it basically just has the same thing in memory. It doesn't do a copy or anything. It should just index the same stuff in memory. Supposedly, that's what I read in the documentation. So hopefully that's working. We don't have like 1,000 copies of different parts of the Sonic ROM hanging around. Okay, so since these are all the same, actually, so notice how we're doing slice offset ROM, slice offset ROM, slice offset ROM, slice offset ROM. So there's a lot of duplication in just, there's duplication, this is duplicated as well. The whole block is duplicated, but there's duplication in that we're slicing the ROM over and over again. I mean, we're using different offsets, but I think we need to basically, we've got our game. I'm gonna add our ROM into this. I noticed this last night. Actually, let me make sure that I've committed everything from last night. I don't think I actually eventually got around to that. I was busy this morning. Yeah, cool. Busy this morning, and so I don't think I got around to it. I did commit it, I didn't push it, so maybe I'll push it. Let's see if this works. It might push, might not. Oh, yep, it's come up my password down here somewhere. Hang on. Okay, so hopefully it's pushing right now. And what I am adding is the ROM content into the game, which is maybe not the best place to put it, since it will only be for loading. Maybe not. Maybe each level. No, I guess we'll be loading later on in the game as well. So maybe we can dynamically load things. I guess you would be able to. So maybe ignore that. So I always import byte string as qualified, just because byte string has a lot of stuff that's duplicated. Like a lot of functions that are duplicated. That means I have to do this. Update all my lenses. This is where like the template Haskell, if I had template Haskell, I did have something where I could go, it was like template Haskell, was it like that? Maybe it was like, I can't remember what it was. Basically, I could write a little chunk of code, and then it would actually print out the lenses for me. So I could just generate the code every time that I modify it. And that was actually really useful. I haven't got it. That's a project I have to take on, which is to make it so that when I develop using Nix, that it automatically brings in that sort of stuff. That's something I'm going to do eventually. I've got if you look on my GitHub, if you're interested in that, look at, what is it? Template Haskell pretty printer or something like that. I have this code up here somewhere. It's basically a way to pretty print template Haskell code. So you can write template Haskell and pretty print it out. Where is it? Okay, I haven't touched in a while. I'm gonna have to search. There we go. Ah, it's not template Haskell pretty printer. It's template Haskell pretty print. So basically, if you give this code, if you call simplify, what is it? Simplified template Haskell, it'll print out the thing. So let me see. I want to show that off real quick, just because it's something that I need to work on and make better. Okay, so I should have simplified template Haskell. So what I can give it now is, I've forgotten how to use this. I give it a, so if I import control lens template Haskell, then I should be able to say make, is it make? There we go, make lenses. So I have to enable template Haskell. Now, how do I use this? I have forgotten how to use it. Okay, so I say, right, something like that. There we go. There we go. So make, what would it be? Make wrapped? No, it's not wrapped. Let me come back here. So you can see with that one, anyway, the make wrapped, that's working. So here we go. So I'm saying print out the simplified template Haskell. Sorry, it took me a minute to figure out how to use this. There's a thing, like it's using template Haskell, so there's an API there that I've forgotten about. But anyway, this is make wrap. This comes from template the template Haskell for lens. You can say make a wrapped instance, and so this will actually generate this instance code here. So it'll actually generate an instance. So I'm saying make wrapped for this A. A is the data type I just wrote up here, so it's A just wraps up an int. So I can say make wrapped, which it gives you a way of unwrapping it and wrapping it up. So here, this code is actually Haskell. So I don't know if I'll be able to paste it in here. No, I can't paste it in here. But, oh, it's because I need to enable flexible instances. Yeah, that's not working because I'm pasting the way I'm pasting in. Oh, actually, it says I need to enable multi-parameter type classes now. Maybe it's. Okay, GDTs, type families. Wow, there's a lot of extensions that are. So you don't really have to enable this, I think. If you, oh, do you have to? You might have to enable this if you use these classes actually. Yeah. Okay. So it doesn't seem, the code doesn't seem to be working, but anyway, the idea behind it does work. The idea that you can dump out the template Haskell, the actual code that the template Haskell generates. Let me see if I can make a. The obvious one would be to do a lens. So let me see if I can make lenses for this. Nope. For some reason, it doesn't seem to like that lens thing. Okay, well I can make a prism. I can make a prism for it, which is actually an isomorphism. So I'm saying that there's an isomorphism between a and int, and this should be valid code. This one should be, at least. Yeah. There we go. So now I've got an isomorphism that I can actually use. So I can say a10, or I can make it into. Yeah, well, I don't have a show instance for a. So I could come up with a good demo of this and show it off, but hopefully that explained it a little bit, that you can actually take template Haskell and pretty print it out, and that's the little library I made, simplified template Haskell. It basically goes through and just gets rid of some like the qualifiers and cleans up the generated code. So really this doesn't really do much. All it does is clean it up a little bit and then converts into a string. So ideally I'd have this accessible in my thing here, in my Emacs over here, and I could just say dump out the template Haskell. Ideally I'd have that. Hey, how's it going? Thanks for saying hello. Yeah, so ideally I'd have an integration into Emacs. I have actually started writing that, but I haven't finished it off. And really, ideally, like the other thing, it depends on my template Haskell preprint library over here. So ideally, I'd actually have that in scope all the time whenever I basically work with anything in Emacs. That for me would require me modifying Nix a little bit. I'll be able to do it, but I just need to modify the Nix a little bit to allow that. I just haven't gotten around to doing that. But for things like this, it would make it a lot easier, because I'd say something like template Haskell, and then I'd say like the lens. I want to make lenses of game, and I'd have it. And ideally would generate basically code that looks like this. Maybe identify names would be a bit different than that, but I wouldn't really care about that, because I don't really care about identify names. Cool. Okay, so that is I've added ROMs into the game. So like the game keeps all of its ROM in memory. And you might think that might be a waste of memory, but it's how big is the ROM? The ROM is 1 meg. So it uses up 1 meg of memory. I am completely fine with using up a megabyte of memory. That's the great thing of working on a game from, how old is it? 25 years old? It's got to be 25 years old, Sonic 2. So that's the great thing, you can just keep it all in memory and then, yeah, not care about it at all. So we got that in memory, so now it's saying, hey, please pass in, when you go to run the game, please pass in the ROM. So I'm gonna change this. So for some reason we're reconstructing it up, but we don't actually need to reconstruct it back up. We just need to modify this this thing here, which we've got a lens for, so we can just lens into it. So I should be able to say set that to that. So it pays to get good at lens, because then you can write code like that. There we go. And here I can actually say O is what is it? It's game camera dot game camera x. Cool. Easy. So I like that a bit better. And now because we have this ROM, now we can load it up. Actually, it's maybe we don't want the ROM in the game. There's kind of two phases that are going on. There's like the loading phase, and then there's the running the game. And so the game has like a camera and a renderer and things like that. Actually, we do use the render and things when we do this. Yeah, I think we actually do want that. We just need to be more granular with our constraints. So at the moment we've got like a constraint of monad reader game, meaning that we want all of the, we want to access this this data type here. But really what we'd have is, instead of these being lenses, we'd have these as classy lenses or classy optics. So we'd have a class saying has camera. And what we would say, so we'd say something like that. So then the game has a camera. But and when we go to use monad reader, we actually say, you know, I want to use the camera, but actually let's do that. Let's just do that. This is what we call classy optics. So it has camera, has renderer. And so what we're going to do now is write instances. So that's the implementation for game. A game has a renderer, and here's how to modify the renderer or get the renderer. And a game also has a camera. Whoops. There we go. So a game has a camera and it has a renderer. And now I'm gonna do similar, but for X and Y. Do I want to do it like that? I think this is fine. I'm just thinking there's a couple ways I could do this one. The camera X. I'm gonna delay that for a little while. I'm not gonna make a decision on that right now. So this will probably not compile because, yeah, so it doesn't have game renderer or camera. Whoops. So I use lenses for everything instead of record fields or anything like that. I'll just use lenses. Hey Derek, how's it going? Okay, so this should be the same program as what we had before, just using lenses instead. And so now, like for example here, I can actually get rid of, what we had before. So notice how we had like monad reader game. What we should have is, instead of monad reader game, because now that we put the ROM in here, notice that this code doesn't actually use the ROM. There's nothing in here that actually uses the ROM. So I would put has camera, because it needs the camera. I need to export that actually, don't I? So in game. Right, so instead of exporting renderer, I'll export has renderer. Notice how I was saying could not deduce that it had renderer either, so it means I have to add renderer as a constraint. So now we're not specifying that we want all of the game. We're not saying that we want everything. We only want to access the camera and we want to access the renderer. So now in our type class constraints here, we're actually saying what the input, like how we can use this function. So we're not actually saying like the inputs to the function, we're saying the constraints on how we can use it. So we can use this anywhere as long as it has a renderer. So that's useful. And so now down here, when I have renderer, this might actually be different because in main I think I've copy sprite mappings. Yeah, so I'm doing all of this stuff outside of this app loop. So I need like what I'm gonna probably make is like a read yeah, I'm probably gonna make like a thing that will load it all up and then run it. So this probably belongs in actually that probably belongs in sprite logic somewhere. All of that belongs in sprites probably. Cool. So that loads up Sonic surfaces, and then I need to load up the textures, which is slightly different. Okay, so I need to import offsets. Okay, now in my game I'm gonna add has ROM. So now I should be able to say has ROM, yeah, G. No, let's put it as a capital but not all uppercase, so I'll make it look like that, why not? I'm not sure if offset should depend on game or game should depend on offset. I'll make game depend on offset. I think that makes more sense. So what I'm going to do is like slice rom. So before we had slice offset, and I'm going to make slice rom, which will just do it but for the rom. So what will it do? Has rom. So this will take an offset and give me back. What does slice offset give back? Byte string. Cool. So we have view. We'll do it like this for now, but I think there's a better way to do it. So I just noticed that I wrote that code, but that's actually that. It means the same thing. So if you do a bind and then a pure, it's the same as fmap. We did that in the Nictor course when we were going through the Nictor course. We did that. So what do I need to import? Control monad reader. Okay. So I got slice rom, and I need to I need to import the offset module we have. So offsets. Cool. I think that is slice rom, getting closer. What's the problem there? Is that it? No. What's the problem here? Could not deduce has rom G0. Oh, whoops, I haven't put an M here. That makes it compile. I need to put the M. So I need the view and the M. Okay, cool. It's just it was the type was wrong. I was saying give me back a byte string, but I need to say give me back an M of byte string. I didn't know what M I was talking about. Cool, so now we've got this slice rom thing. So where I was having this sprites, I should be able to say slice rom, sorry, I should be able to say sonic content is slice, instead of slice offset like I had before, I can say slice rom art sonic. And notice how I don't mention rom here. The only mention of rom is in my slice rom function. So it's just a bit nicer because I don't have to keep passing rom around. I've got it kind of implicitly in scope. And some people call this like, I don't know, functional dependency injection or something like that, but it's just called the reader monad. And it's a little bit nicer because we've got the optics that I've written, the classy optics. But things are pretty easy to rewrite into this. Everywhere that we had like this binding, we can now change it a little bit. So this has got the idea of a palette, so I might need, yeah, sprites probably should depend on palettes. I think that's fine. Oh, whoops, there's no read palette. Okay. Was that back in main? Was there a read palette in here? Where's the read palette come from? Oh, it probably comes from my library that I wrote. I made a separate library for doing palettes. I've got weird module names. I've got like sega.megadrive.palette, and I've got game.sega.sonic.offsets and stuff. Like, I need to probably make that more consistent. Okay. I need to do something there. Yeah, we need to do something there. Okay, I can do something. I've got this one big error type at the moment, which is also something that's not good. Ideally, each one of these would be a prism, but we can talk about that later. But notice how we're not mentioning ROM anymore. The only mention, like, we're not directly mentioning ROM. There's no actual reference to ROM. It's all slice ROM. So we've got this separate function that goes off, reads from the environment, and does a slice. I'm going to call this load Sonic for now until we generalize it. What do you think of game development in a non-object-oriented programming language? Same, like I do everything in Haskell, so like game development is not any different for me. It's just another type of development. It does make things hard because like there is one tricky thing, which is that STL, for example, is quite imperative and mutable. So let me see, where did we have that thing before? I showed this off last night, but under the STL2 libraries, there's high level and low level things, but even in the high level API, you have state vars. You've got these gross things. So you've got this renderer render target, and so this actually talks to like to our like global renderer thing that we have. So we've got this like renderer which is tied to the back our window. When you start up a window, you can get access to a renderer, and you have to set the render target for that renderer. And so whenever we go to like copy a texture to another texture, we set this global mutable variable to some sort of value, so some sort of texture. So we can either say like when we go to render one texture to another texture, we set this to just some other texture. So we say we want to render what we're rendering was going to now go to this texture. And then if we want to, like, when we unset this, if we set this to nothing, it actually starts rendering to the window. And so it's a little bit, it can be a bit confusing when you're rendering something because you've got this global mutable variable and it depends on the state of this as to where things are going to get rendered. So it's not a nice API to work with in Haskell because it's a global mutable variable, and we can do it in Haskell, but it's just, global mutation is just not good. Like, it's just not a useful thing to do. So working with this API kind of sucks because of that, and so it doesn't really go well with how I would like to do things in Haskell. It's possible, we can just do imperative programming in Haskell. Haskell is really good at imperative programming, but I'd like to see something that doesn't have global mutation in it. So I guess game development in a non-object-oriented programming language. I'd say that in Haskell, it's possible for us to be exactly the same, but I'd like to do a little bit better. I'd like to do, instead of having global mutation, I'd like to do a bit better than that. But in the worst case, like the way I'm using it, it kind of is like writing, like a little bit, when you get to this sort of stuff, it's kind of like just writing C to me. Are there any functional SDL2 replacements? So some people were talking about gloss yesterday, and I wouldn't say it's an SDL2 replacement, but oops, brought up that. So gloss is a really cool, vector graphic library, and so people are talking about that. I don't think it would be good for what we're trying to do. We're trying to re-implement Sonic. I don't think it would be performant enough to do that. But this is a really cool library. It's a really cool library. It gives you composable images, and so you can kind of take, I don't know, I showed off some code yesterday, but like you can take pictures and concatenate them together and you get a new picture. So there's like actually an algebra behind it. It's really cool. It's an algebraic way of rendering pictures. But it is a vector library, and so it doesn't really make sense for Sonic, but it is a really cool way of working with graphics. So I don't think there is anything that's like very performant for SDL2. I know that like pixel shaders and stuff are some like I don't know. I haven't really done much with pixel shaders, but I think there is some sort of functional programming in pixel shaders, but maybe not a lot. So I don't know. I'd like to see something more functional in SDL2. I think when it says here it's got low level and high level, I think the high level could even be even higher level. What about memory management for game development? How is that done in Haskell? That's a tricky question. It's a tricky question. So the memory management is not, like, for the game that we're making, I don't think is going to be a massive problem. I don't think garbage collection is going to pause our frames or anything. Obviously you want like a constant frame rate, and so garbage collection could be a problem if you're garbage collecting, you know, every, you know, if you're generating garbage and at like every 30 frames or something you get a big pause and it slows down, that would be bad. The thing with Haskell though is that we've got a concurrent garbage collector, so I think we'd be pretty safe from that. And I think in the worst case, even if we did do like a full GC in between certain frames, I don't think it would be massive impact. But we'll see. I think that'll be something that we'll have to, either it won't be a problem, or we'll have to answer that later. But I doubt it's going to be a problem for us. Can't you grab that mutation in something and get safely from it? Yeah, we could get safety from, yeah, we could wrap it up, make it better. The thing is, like, this is the SDL2 library. It's got high level and it's got the low level stuff, so pretty much a one-to-one translation of the CP API. Then they've got high level, which works a little bit higher, but yeah, enumerations are split into some types, perform automatic error checking. It could go even higher than that, yeah. So they have just basically wrapped the C API. They've added a couple of things on. We could go further, and yeah, maybe we could wrap that state up in a way that is more safe. That would be ideal, but we haven't gotten that. Okay, apply dynamic. Where'd that come from? It comes from tiles. I'm just making sure tiles doesn't depend on sprites. It depends on sprite mappings, but not sprites. So I think we can import it in. Haskell will say if we've got a, what you call it? Cyclic import. It should do. The cat's next to me. She's asleep. This is on my GitHub, and I think I've just pushed. Let me just double check. Yes, I've pushed. So if you go to my GitHub, it should be linked on my Twitch page. But if you go to, that's not what we're doing today. We're not doing the FP course. We're usually doing the FP course, and so we've changed it up a little bit. Yeah, this is on my GitHub. I've got it here. I haven't got a README or anything interesting really, but you can actually download this and run it. If you run it though, you will have to have a Sonic ROM. I haven't distributed a Sonic ROM for, you know, for legal reasons. But if you can get a Sonic ROM somehow, oh, don't look at that because that is the Sonic ROM's content, so don't copy that down. But yeah, if you get the Sonic ROM and you put it here, and you have to call it sonic2.md. If you name it that, I mean, if you run it, it'll just say, hey, I haven't found sonic2.md. So put sonic2.md in that directory, and then you can run it. And you should get, well, actually this is not compiling, so I can't show you right now. Let's get this compiling. I'll hopefully be able to show it. Markdown. It's meant to stand for Mega Drive. I'm not sure. I found a ROM online and it said .md. I thought Markdown at first as well, but it's supposedly, I think it's meant to stand for Mega Drive. I actually had an error report saying Markdown. Where do I get this Markdown file from? Okay, we're getting through it. Renderer. And it needs to be is it surface, is it? That can't be right. Yeah, that's not right. I don't want... Where'd that low tiles come from? Oh, I had some weird thing. Oh, okay, that's where Sonic... Okay. Okay, let's go back to that. And this gives me a what? List of sprite mappings, textures. Is there a general pattern for Haskell apps we'll follow for applying configuration, or is it every programmer for themselves? What do you mean by configuration? Applying configuration? Do you mean like dependency injection type thing, or yeah? Let me know what you mean by dependency injection. There is a pattern that I'm following right here to do what I would call configuration. I'm just not sure if that's what you would call configuration. Okay, we have a function that will load up Sonic. It's a general function that will load up Sonic. The next thing will be like just to generate a sprite from that. So that's load Sonic's sprite mappings. Okay, so I'm just thinking, I think the goal is to, this. So we'll load up an animation, it'll load up textures, it'll load up animation, and then do the initials, like give us the option to like, you know, give it the position and the animation state to start off with. I think that should actually be empty by default. So I think the only thing is like you really have to supply is like, I guess what you'll have to supply is like a data structure that represents Sonic, and a data structure that represents Tails. Yeah, maybe that's the place to start. Things like database schema, network stuff, passwords. No, there is no standard. There is definitely no, or not even a general pattern. No, that's very different depending on whoever wrote the app, what the app's used for. Yeah, it's very different pretty much always. Like we don't have JDBC or anything like that. Is there something you generally follow for this stuff, or is it dependent on the application? So for DB schema, network, mumbo jumbo, passwords, is there something you generally follow for this stuff? No, not really. I wouldn't say that there's anything general. Like, I mean, I know that like Java and similar things have like JDBC, and I know that Python's got quite a few of the different, you know, configuration formats and that. Haskell's got nothing like that really. We do have a few like really core libraries that pretty much everyone uses for like depending on what they need to do. Like I can list a heap of things that are like core libraries. Like there's ASON, which everyone uses for. Thanks for the follow, Shikata. So ASON, everyone uses that for JSON stuff. There's configurator, which people use for. Is it configurator? People do this for like certain configuration, like reading configuration formats, but they usually come up with the format themselves. And there's optparse, applicative. So I think this is like heading in the direction that you're talking about, like commonalities between applications. So you'll pretty much find like any application that needs to read from, needs to do option parsing is probably using optparse applicative or something very, very similar to it. Anything that's trying to like load configuration files and that is probably going to use something like configurator. Anything doing JSON is almost certainly going to use ASON. Okay. Okay. Sorry, I thought you might have been talking about configuration that's common between things. So you can set like configuration, but that's common between all the Haskell apps. But no, there are just libraries that we have that are very common between all the I don't know, I guess between all the applications that we write. So ASON, configurator, optparse applicative. There's heaps and heaps of them. I can come up with a list of them. I think what you can do is where is it? There's haskelliseasy.com. Is this the website? Haskelliseasy.com lists a lot of common libraries, recommended Haskell libraries. Maybe this is what you're after. Would this answer your question? List of recommended Haskell libraries? Haskelliseasy.com has this. It does recommend Stack. I don't recommend that. And there was a massive Twitter argument about me not recommending Stack, but I don't recommend Stack. But anyway, all the rest, like Criterion is a really good benchmarking tool. There's serialization. There's binary or serial is basically the two things that people use. I prefer to use something called Tickle, which is basically a fork of one of them. I can't remember which one. It's a fork of one of them. Cassava. Yeah, like, there's just all of this stuff. It's just these are like a lot of recommended libraries. So hopefully that answers that question. Okay. Where were we? Yeah, okay. So I need to load up the mappings, but I need to load up the mappings with a game in scope, yeah. So I need to I need to do that. So I'm gonna make, so at the moment, so you notice how I've written everything in main, which is not great. So I've written everything in main. What I'm going to do is now separate all of this out into like a load and run function. Yeah, load and run. Okay, so I'm just propagating the constraints up from this function. Okay, so that will load up the Sonic's mappings, and now I'm going to modify this a little bit. So I'm moving the app loop down here. So my app loop has been like the main function I've used so far. Okay, so that's a thing though. I need to. I need to modify the game. How long have I been using Haskell? I've been using Haskell since 2018, and I've been using it since I was probably about 8-9 years or so. I've been using Haskell. Somewhere around there, I've been using Haskell. Thank you for the follow, Jahisek. Thank you. Come on, kitten. Get out of it. Okay, so now I'm going to start, I guess, getting rid of some of this code. Yeah, I probably should get rid of it. Here's one thing I need to do. The render type, this is the mutable variable, right? So in the game, like when I'm rendering sprites, when I load them all up and that, I actually change this a lot, so. This is where I need to like reset it before I actually start running. Before I start running the game, I need to actually reset the target so it actually renders to, like, I need to reset it to nothing so that it actually renders to the window. Thought I was going to say since I was 8 years old, that would be awesome. No, I think I was like 19 or 20 when I started doing Haskell, so. And that's what I was trying to calculate. Hey C bro, how's it going? Render is not in scope. That can't be right. What did I have there? Render must be something I wrote down here somewhere. Yeah, it is. Good dude, actually a bit inspired by you and others, I started streaming programming. Awesome, cool. What are you streaming? 2 streams so far, pretty fun but stressful. It's lots of fun, it's awesome. It's good to show people, well for me, I really like showing people Haskell, so I really like this. Okay, let's get through it. Go and cloud related stuff, okay, cool. Actually, I think I do need to pass that Sonic and Tails thing back in. We haven't gotten that far in the refactoring that I can get rid of those yet. I just realized that Tails is actually a function in Haskell, so that's gonna be, yeah, that's probably gonna be a warning saying, hey, you're overriding Tails. Forgot about that. So I've got this thing called Sonic Textures, but it's actually Sonic Mappings now. Sonic Mappings. I've renamed it because it's actually mappings instead of textures. I think it's a mapping of textures, but still. I'm actually going to say Tails is using Sonic's mappings for now. I don't know if that's going to break everything, but... My kitten's climbing up me. Come on. But kind of just a bit of entertainment, lucky enough to have a body dial into code while I produce. Commentate. Okay, that's cool. so I just need to pass in chunk textures. That's where I'm doing like the dodgy error stuff. So actually that's what I'm going to lift that up a little bit actually. Yes. Cool. And then this is where I'm going to do the run except T stuff. Come on. What is it? Load and run. That's what we call it, isn't it? There's actually a couple of things we need to do, isn't it? I think we actually need to do that. Oops. Pass the game in. There we go. I'm just going to be specific for this function here. Trying to get this to get close to compiling. That's going to be the current goal. Here we go. So I've render level block. It's got a byte string as the reader. Right. Okay. So we are passing in this is meant to be the ROM, and we've done better than this now. So we've got has ROM now. So this was like the start of my dodgy thing, and now we can actually say view. We don't even need to go view because we've got that thing, so we can actually say, I think this slice ROM. Yeah, cool. So this is a little bit nicer. Getting better. What's wrong here? Oh, yep. Just need to modify the constraints. So it says monad reader of byte string. Just because I did like a really simple version to begin with, and now we've done a little bit better. So now we don't actually have to say. Don't have to say what type of the monad reader is. We can just say stuff like that. We can just say slice ROM at that collision. We don't even. Yeah, it makes it a little bit more simple. Cool. Yeah, refactoring is really so easy in Haskell. Really easy. Okay, so we've gotten a little bit better. So that one's a renderer. Ah, there we go. There's another thing. So I was passing in a renderer before. Don't need that because now I have it in my. I can add it as a constraint. So now I can say as renderer. And this is going to propagate all the way down. So nowhere should I see a reference to renderer unless I am doing something directly with SDL, and none of these things actually are. So I'm just going to keep propagating it down. And this is going to go quite far, because I remember putting renderer as an argument to pretty much all the functions. So it's a little bit annoying, but... what's the problem there? Needs to have the node reader. What's the problem? Oh, yep, I've got renderer. This is a little bit dodgy as well. I've got this dodgy empty texture thing, but... So here, notice how we're actually doing something with STL. This is actually a function from STL. So that's where we kind of have our boundary. So I have to say, view the renderer, and then pass it in there. So now I'm going to say has renderer. Like that. What's wrong with my reader? Ah, G of M. There we go. For some reason, my Haskell formatting stopped working. Hopefully that'll solve itself later on. So it's good when you can actually take away arguments from a function, and all you have to do is change the type slightly. And if anyone wants to, if anyone's confused by this, this is called classy optics. This when we have like has renderer, or when we have like when we say has is, this is usually a convention in Haskell. If you've got a type class that starts with has, we call that a classy optic. In these cases, because in these cases, specifically they're classy lenses, because the actual method on the type class is a lens. So we sometimes call these classy lenses, or the more general form is classy optics, and that covers like a lot of different forms. But basically, when you see has, you can say basically it has a classy, you're using a classy lens. And then what we're doing is we're saying that's a constraint on the thing that you can read from the environment for reader. Yeah, so we can start making type classes that combine things like monad reader and has renderer. But there's sometimes where I want like has renderer and has camera. Yeah, we could actually make one that like combines it together and like has renderer reader or something like that, where it actually, you know, is just a reader monad or whatever. But yeah, one good thing is that because we've specified as a lens though is and we haven't gone all the way to reader, is that we can use this view function. So I can say view, and I should be able to say view renderer. And I can compose that with another optic. So that's another useful thing to do. Actually, copy sprite tile is another thing. So we can keep going further. So this is, we're just, you know, recursively going through and deleting this, deleting the reference to renderer. And these are two cases. These are actually two calls to SDLs. That's where we're going to actually use the view renderer. And it'll say we don't have a renderer in scope, so let me add that into scope. Whoops, has renderer. Cool. Okay, sprites.hs now. 127. What's happening there? Could not deduce mind reader GM. Wonder what's going on there. Oh, because I haven't got it in. As renderer. There we go. That's why I couldn't deduce it, because it, yeah, it actually was telling me a useful error message if I understood it properly. Cool, so this doesn't even refer to renderer directly now. We're going up to main, so I guess we're actually at the end now. We should be getting pretty close to being done. I don't actually think we use these collision textures, so I might be able to delete them, but I'm going to keep it now, for now. What's the problem here? We haven't done this one. Oops, so we've already got lens and scope, so let's add view. What is it? Has renderer. And we need to import monad reader. Is monad reader in scope? No, it's not. Okay. Collision has got a problem. That's what we're in, isn't it? 42. Oh, I'm not actually doing that. I'm not actually passing it in anymore as an argument. It's being passed in using the context, using the reader monad. Go back over to main. I shouldn't say reader monad. It's a weird thing to say, reader monad. It's a very weird thing to say. What's the problem there? Not sure what the problem is for that. That seems reasonable to me. I don't know what's going on with that. Word 8 texture and's got a texture. Am I looking at the wrong line though? I am looking at the wrong line. Why did that take me to the wrong line? Yeah, it did. It took me to the wrong line. Okay. Line 50. This is what I need to be looking at. But why have I got this error? Oh, it's because I haven't refreshed this. There we go. I'm using a fly check. Is it fly check? Which doesn't automatically, like if you modify a file that fly check depends on. So if I modify this file and this module depends on this module. If I modify the, like the actual dependency, if I modify this and I fix up whatever problem was causing it up here, this doesn't actually get refreshed. So sometimes I get confused when I go and fix the problem and I come back and I'm like, okay, let's do the next error, and the next error is actually the error that I just fixed up. And I get confused and I try to look into the same thing again. So it would be cool if fly check detected when things get updated. Really what I should do is probably rely more on GHCID over here, which is more accurate. It's always accurate. It's never been inaccurate for me, so. Where's load chunks? Okay, we got rid of renderer there. So this has all been the same problem, but it's good because now it means we have something that's a little bit more specific about what it takes. So you can see that before what we had was like passing in the renderer, and then we can. Well, I guess this one's not actually more specific because it's we're just converting into monad reader. But I don't know, when we pass things around, like we don't actually have to pass individual parts of a function around. We don't have to pass the actual inputs. So before we were passing renderer around, like you can see renderer was referenced all over the place. And now it doesn't have to be. It only has to be referenced when you actually got to use SDL. Is everyone confused by what's happening in this? It's a little bit involved, this classy object stuff. Here's another thing. So you notice how it says monad error and we're saying sonic error. Notice that the error that we actually use is not all of sonic error. We use one error, one possible error. So really we should be more specific. We should be able to say as. I think as is another convention. So we have has, which is like a lens. I think as is like a prism, so I think we should be able to say as empty chunks error e, like that, and then you can use this as a prism. So that's another thing. So it's classy prisms and classy optics, and so classy prisms and classy lenses, and so I've been using classy lenses, and I haven't gone through and done classy prisms yet, but that's another improvement that we can make. So generalize this from sonic error to anything that can be, anything that's an empty chunks error. And sonic error is one of those cases, but it may not be all of them. So kind of make it more polymorphic. So monad IO is gone. Why is monad IO gone? I did accidentally delete it. There you go. And so load chunk currently takes a renderer, and we're going to do the same thing. And just copy and paste these constraints that we've added. So I need to have has renderer up here. Cool. Getting there. Okay, so now I need to say, so in 87, line 87 uses errors. So line 87 says load and run needs to have monad error, sonic error. Okay, we can add that on. No problem. Whoops, what have I done? There we go. What's happened here? Okay, back to where we were, 87. So we should be able to say monad error. What was it? Sonic error. Cool. Okay. Compiles. Now, I hope that this works just as before, except the only thing was with tails. With tails, we actually didn't. The tails mapping that we'd have is actually Sonic's mapping, just because when I translated it over, I actually just copied Sonic's mappings and not Tails's mapping. So we've only got one, which is Sonic's. So we'll have to. That's the next goal. After we do all this, we'll have everything in place that I can kind of generalize it to. We should be able to load up Tails and Sonic using just a data structure. So instead of having load Sonic sprite mappings, it should basically be like load sprite mappings. I should be able to give it, Tails' offsets, something like that. That's the next step. So load and run, it will say couldn't match type exception with Sonic error. So what it's trying to do is say that so monad error, there's an instance for IO as long as it's an exception. We don't have an IO exception. We have we have Sonic error. What I'm going to do is run except t. And now I have an either. I should have an either from that. Except this will also say monad reader game IO. So I should be able to say run monad. Oh, sorry, run. What was it? Reader t. And now I need to give it an initial game. So the game will have initial of what's the 3 arguments to game? It is the renderer, which we've got. And then we have the camera, and then we have the ROM. There we go. I'm gonna print the. Actually, I'm gonna. So E will either be unit if it's successful, or it'll be an error. So I'm actually gonna say print. I'm just gonna print it out. So there we go. So either we'll take this, if it's a left, which means an error, it'll print it out. If it's a right, which means, we succeeded, it'll be a right of unit. So we can just say pure, just put that into IO. And E is our actual either type. So there we go. Hopefully I can run this, and hopefully things will look normal-ish, except Sonic, there'll be 2 Sonics on screen instead of a Sonic and Tails like we had before. And the weird thing is that it's going to use Tails as animations over Sonic, so I don't know what's going to happen, but we'll see. Okay, we broke things severely, it looks like. It's not loading up the chunks, like it said, like it previously did. Okay, so things are pretty broken. Why is that? What did we break? No, well, that might. Oh, there we go. That's probably a start of it. Although it should still say loading. I don't know why I didn't say loading. What I just noticed there is that the renderer, we were setting it to nothing, but we're setting it to nothing too early because we loaded the chunk textures after that. There we go. Okay, cool. That is actually working. So this is what I was saying about the global mutable state. Notice how I made a bug, because the only bug I just had just then, after doing this massive refactoring, right? Like, we all agreed that I did a massive refactoring. The bug I had was due to what? What was the bug caused by? Look at that. It's the global mutable state. So, the one bug after a massive refactoring is always global mutable state. So get rid of it. Yeah, so it's actually, you can see that it's using Tails as animation, so it's pretty funny. It's a little bit funny that he's doing that, but yeah, it's using Tails as animation over Sonic sprite. So we do have two Sonics, and now what I'm going to do is, I'm actually pretty happy that, we did a massive refactoring and it pretty much worked, except for my global mutable variable that STL forces us to use. So now what I'm going to do is, so now that I've got load Sonic sprite mappings, we're going to abstract that so it's load sprite mappings, and then we can say either Tails or Sonic. So what I have in my offsets file is I've got Emerald Hill Zone as a level offset. So I've got a data structure that represents like all the offsets for a level. And so now I'm going to make like a sprite offset, I guess it is. Thank you. It is pretty cool, isn't it? It is pretty cool. So what does Sonic need when we have the sprite? When we have load Sonic sprite mappings, we need, what do we need? Slice from, we need art. Okay, so we're going to say sprite art. And what else? We need mappings. So sprite mappings. Sprite mapping. That's a bit confusing because like there is actually something called a sprite mapping, but we'll go with that for now. So there's a sprite palette. I think that's right, sprite palette. And then there's this DPLC, which is a dynamic pattern load queue. Is that right? Dynamic pattern load queue. Oh, I was right. It's a dynamic pattern load queue. Sprite DPLC. I think that's gonna have to be a maybe in the end because I think I think Sonic and Tails both have a DPLC, but I think most sprites do not have a DPLC, and so I'm gonna have to probably make that into an option later on or a maybe later on. But that's what it is for now. Anything else we use slice from on? That might be it. That might be all the offsets. Now let's write down the ones for Sonic. Sure. So Sonic art, or is it art? Art Sonic. Mapping Sonic. Palette Sonic. And DPLC Sonic. Then we're going to have one for Tails, which is going to be pretty much the same. That's the one that we are. So with Tails, we spent a little while last night figuring out where Tails was. We had to look through the ROM file and do like a hex search of the. Oh, there we go. Palette Sonic is actually what we use for Tails as well. But we had to do a hex search in the ROM file to figure out exactly what was going on there. Okay, so now we've got these offsets, and now what I'm going to do is generalize this to instead of taking instead of loading up just Sonic's art, like instead of directly referencing all of this art, we're actually going to generalize it to load sprite mappings, and it is going to take sprite offsets. And so content will be what's the sprite art, sprite art. Sprite mappings of offsets. So right, sprite mapping, wasn't it? DPLC is the sprite DPLC. Sonic surfaces is just surfaces. Sonic content is just content. Sonic palette is maybe palette. Cool. So we now have general load sprite mappings. So now if I go back to main, if I try and compile this, it should say no. So delete that and I say Sonic Tails. But I've already got, I'm going to rename those things. Instead of Sonic and Tails, I'm going to call it Tails' offsets and Sonic offsets. Okay, so hopefully just doing that, I should have now Tails and Sonic loading. Hopefully. Oh, I was worried a little bit they were not animating there, but they are animating. Cool. We're back. Yeah, we're back to how we had it. Before we had it all hard coded. Now we've got functions that generalize sprites. So I'm happy with that. That's cool. So I'm going to commit this because we made a lot of changes. There was one where the formatting was broken, wasn't it? This one. I'm still not liking the formatting. I don't know why. I'm not sure why. I use stylish Haskell, so let me just manually call it on the thing, and we'll see what it says. What is this file? This is blocks. There we go. Multi-parameter type classes is not enabled. There we go. That's the problem. Which is actually just a bug in stylish Haskell. There is no, I don't think there's any need for multi-parameter type classes, but I don't know. It's fine. I don't mind putting in extra things, extra language, things like that. Oh, whoops, I think I added it to offset the spell by accident. Okay. I think we're good. Use classy lenses and generalize sprite loading. Okay, so what I'd like to do is maybe load up some more sprites. Actually, I think there's one thing, which is our animations, I think is duplicated. Our logic around animations is still duplicated. I'm just doing that to get rid of the warnings, because I've got something called renderer, so it's just giving me a warning about it. Really, I should be compiling this with all warnings enabled, but okay, yeah, so we've got this animation here, yeah. But that's not that bad. Like, the duplication is really, I mean, there is a little bit of duplication between these two, but it's not actually that bad, is it? Yeah, I'm okay with that for now. I'm gonna continue on from that. What we should do is probably so notice how we got this app loop, and we like got this Sonic and Tails. We're kind of recursing around, and we're updating the sprites. Really, what we should do is probably have a list of sprites that we want to render, rather than specifically having Sonic and Tails be two sprites that get passed into the app loop, and the app loop updates them and everything. Really, we should just have a list of sprites that goes through, and it updates each sprite in that list, and then renders each one. Ideally, we do that. I'm just looking at we are running this, so I think like if I got rid of that, if I did this, it's the same. So I think I can use in monoid reader. Sorry, I'm noticing refactorings in my head. I've noticed these things before. This is I want to use. Is it local? I think I want to say. Is it local? That's basically what I wrote. Okay, don't worry about that. Thank you, a sniper, for the for that follow. Sorry, I've got the alerts coming up on my screen. I just don't have them coming up on my thing for some reason. Hang on, I'll see if I can fix that real quick. Yeah, there we go. That breaks everything. That looks broken, doesn't it, on your screen? Yeah, okay. I'm getting rid of that. Yeah, for some reason I updated OBS and things are broken, so notifications aren't coming up, but I'll at least shout them out anyway. Yeah, so I'm ignoring that. So yeah, let's modify this to be like a list of sprites to render. I think maybe this should go in our game. Should it go in the game? I'm not gonna put it in the game for now, and the reason is that I think there's a cyclic dependency if I put it in the game. If I'm separate out my data types properly, I could put it in there, but hang on, what's happened here? Now that I've gotten rid of... That compiles, and then if I come up here and I say, pass me in sprites instead, and I come down here and I say sprites, oh, I know the problem, I think. Do you recommend Haskell Book as the best resource to learn Haskell? Yeah, Haskell Book is extremely good. I do recommend Haskell Book a lot. It's really good. For everyone else, if anyone else doesn't really know Haskell that well, there's Haskell Book. I highly recommend this. It's really good, really good. It's a massive book. It's over 1,000 pages. And it's really well written, and it's got a little bit of everything for everyone. Like it's got the beginner stuff, basically how to start doing functional programming. It is also programming for beginners. Yeah, so there's some stuff. Yeah, it does start up with being it's really basic. It does start off with being really basic. It does go into like some beginning functional programming things like algebraic data types and that. So that's useful stuff if you're beginning with Haskell. Then it steps up a little bit, and then it starts going like, I really like these composing types and monotransformers. Those are really well written things on the topic. So if you Google monotransformers, you'll come up with like a heap of different confusing things. The Haskell book does a really good job of motivating it using composing types. That's a really good chapter that motivates monotransformers. And then this one actually explains what monotransformers are. So there's some good stuff here for like people that are intermediate in functional programming, people that have done functional programming for a while and then, or at least kind of started doing it, but want to learn a little bit more. The Data61 FP course is also really good. We've done that on the stream. So if you look up the Data61 FP course, it's a really good course. So if you are, I guess if you're a little bit bored with the Haskell book, because it's programming for beginners, you can have a go at this, which will actually teach you just Haskell. So it starts off. It does start off a little bit slowly. You're meant to kind of just look at this code, and the first one is how to work with optional. But it does ramp up pretty quickly actually. So you do course.optional, which might be a little bit easy depending on what experience you've had with Haskell before. But list gets a little bit, there's a little bit involvement in list, especially if you put constraints on yourself. So for example, when I do it, I try and get people not to use pattern matching as much as they can. So try and use the fold right, fold left as much as they can. So that makes it a little bit difficult, makes it a bit interesting. And then you've got functor replicative monad. So if you're getting started with Haskell, this will probably be new, functor replicative monad. So yeah, there's some really good exercises in here. So if you're interested in just learning Haskell by itself, this is a really good course. I guess it's not specific to Haskell. It's really a functional programming course, but it really does step you into like Haskell syntax and the common libraries and stuff inside of Haskell. Yeah, if you're tempted to skip chapters, the book says don't do that, but I probably would. You can always go back. If you skip something and you go, oh crap, I shouldn't have skipped it, you can fix that. Okay, so now I've got a list of sprites to render. Cool. So there is some other animations in the disassembly. So there's these flowers. I wonder if I can load these flowers up. I'm looking in the uncompressed directory because like there are some. So Kaczynski is like all the stage things. Nemesis I think has a lot of the other actual art, like all the enemies and stuff like that. And we haven't done Nemesis compression yet. We don't have that. So I'm going to like. I mean, I'd really like to do the Nemesis, like load up like an enemy or even like I think the rings are in here. Yeah, rings are in here, but we don't have Nemesis compression. So I've done Kaczynski. We can load up uncompressed stuff. I just looked at like the uncompressed stuff, and it looks like there is like, it says flowers somewhere. Animated flowers. Is there? There is flowers somewhere, isn't it? Oh, Emerald Hill Zone and Hilltop Zone flowers. I think this is animated sprite. Maybe not actually. Look at that. Now that I'm looking at this, I'm reconsidering. Maybe it's not, because there's not much there. There isn't much. But let's actually. So that's the other thing. Whenever we want to do animation, we actually have to look at the disassembled code and find the animation. So that we had Sonic animation. So Son Annie. I wonder where the flowers are. Animated Emerald Hill Zone. Okay. So these are the animations for flowers. Yeah, so flowers 1, flowers 2, flowers 3, flowers 4. Okay, so this is the this is the animation for it. I wonder what this 7F is for. 7F. So I know DCB is like DCB is like load a byte constant, like put that into memory. So I'm not sure what the first, like usually when I see DCB, like I think in one of the Sonic animations. If we go to the wait animation around here, there we go. So you can see here it's loading up all the... Okay, so I guess that's just the second part of it. Okay. So DCB, you kind of give it a whole heap of bytes and it loads them all up. So I think those flowers... It's Hilltop Zone. I want to see the Emerald Hill Zone one. Emerald Hill Zone, here we go. So I think it's loading up. I think these are just all the bytes. So it loads up. It says that starts off with 0. What would that be? Because I've put that as a delay. I've put that as a delay, so I'm not sure what that means. And I'm not sure what 7F would mean. So I guess that would be, I don't know, I guess one of the oh, that is the frame duration. Okay. Tile ID of first tile on the flowers to transfer. Frame duration only here if global duration is -1. What's that mean? It's good that someone's disassembled it and tried to document it, but yeah, comments are not a great way to document it. We don't really have any other tools, but it's just, yeah, this is super confusing. Frame duration only here if global duration is -1. I don't know what that means. Okay, it says up here though. Global frame duration if -1, then each frame will use its own duration instead. Oh, yeah, instead. Okay. Oh, okay. So I guess 7f is -1. Is that right? No? No, I don't think so. Yeah, I'm not sure. I'm not sure. Wish I had like a Sonic hacker person that I could ask these questions to. I know Haskell really well. I do not know what this means. Posting thing against checkered background. So I think everything at least after the first two is the animation frames. Who made it? Can you ask them? Who made the disassembled Sonic ROM? A group of people. I could probably start emailing people, yeah. Clownacy. Clownacy is the most recent person working on this. That says 7 months old. I know that there's been more recent work than that, so I'm gonna update. I think it's pulling. There should be more recent commits than that. Oh, it's not pulling because I've got to type in a password down here. There we go. Clownacy is the main person behind this. So I could start emailing Clownacy and say, what did you mean by these flowers? Oh, Clownacy streams? If Clownacy, awesome. Clownacy streams. Thank you so much. That's really good news. Clownacy Twitch. Oh, on YouTube. Okay. Let me look at this real quick. Interesting. Cool. That's really useful. Thank you. That is really useful. I might talk to this person. It would be a good resource to have someone that actually, you know, knows Sonic a lot. Hack of Sonic 2 where I've tried to fix every bug I can find. That's awesome. Yeah, that's why people do this sort of stuff, so that they can actually fix up the game or improve it in some way. So, yeah, that's cool. Clownacy GitHub. Suppose I should look up at this person's GitHub. Clownacy. That's awesome. Good job, Clownacy. Yeah, I should start talking to some people. These people would help me out, I think. Yeah, but anyway, I'm gonna have a go at trying to figure out this. Like, when I was originally trying to figure out what like Sonic meant, I actually, like, you know, kind of took the tile information, rendered it all to screen, didn't, you know, put any palette on it or anything, just kind of rendered it, and then looked at the tiles and kind of looked at a reference image and kind of compared. So I'll probably do that with this in the end, because I don't know, that does work. It just takes a bit of time, so I probably won't do it on stream. But if I can't figure this out, I might just do that. Just render what I have, and have a look at it. Another thing is, like, looking at patterns. Like when I was looking at, I think what was it before that we were looking at? We're looking at the DPLC information, I think it was. Where did that go? The DPLC was around. Yeah. So previously I was looking at this. I was trying to figure out what this format was. I remember on stream a couple of weeks ago I was trying to look at this and figure out what it meant, and then I noticed that they're all incrementing. I actually mentioned it on stream. I said, these are all incrementing. What does that mean? And I realized, it took me a while, but I realized that these are all offsets into the file. So see here, it resets to 0, 0. But all of the ones before that are actually indices, and so these are actually indexing. So 0, 1, AC is actually an index. So 0, 1, AC is actually where that 0, 0 starts. So it's really just, so if you look down here, hex address 0, 0, well, it's gone. 0, 1, AC, which is what the first line says. So, I noticed that, and then things started making sense, and I'm like, okay, well, that's the offset. So then I looked at this one, and then I was able to compute everything based on that. I was able to reverse engineer it just by noticing patterns. So maybe if I look at the art and look at the animations, I might be able to see a pattern and figure it out from that. The good thing is that once I do this work, it's in Haskell, so I'll never forget. But yeah, I don't think I will do. I wanted to do the flowers, but that looks a little bit more complicated than what I'm willing to do right now. So where can we go? Maybe we should start working on moving Sonic. I really want to get to like Sonic's, what do you call it? Sonic's physics. So that would be really fun. I would really like to work on that. I think the rest of the thing can kind of wait. We do have all the collision mapping. I used to have a little thing that you could press to actually show the collision maps, but I've taken that out for now. But the collision, I do actually have the collision data. So I've got Sonic, I've got his collision data, I've got all the data that I need to be able to compute where Sonic is. So I think I can actually start moving him around. So I think I will actually work on that. There's actually a really cool, on that Sonic Retro website that I keep referencing. Sonic Retro. I think there's a physics guide or something. Yeah, Sonic Physics Guide and the Sonic Retro. So this is really cool as well. So you got solid tiles, and this is useful because it tells you that I've read this before. It said something like you got top and bottom things. So you got things that are like solid from the top but may not be from the bottom. So for example, Sonic can kind of jump up on a platform from the bottom, but he can't fall through it from the top. So there's little things like that. And so we've got the height masks. We've already got that logic in our engine. We already know the height mask of all the tiles. And it says here Sonic has a sensor that looks at height value. Sensor has to check. It does have like a size of the sensor. So there's a sensor basically, and it goes. The sensor says like, here we go, horizontal. Okay, so he looks. Sonic, you get Sonic's position. You look at take 10, and you look at plus 10. So you go for every pixel, take 10, and every pixel plus 10 from where he is, and that's where you can figure out what he's colliding with. So you look, you keep going back. So you go -1, -2, -3, -4, and if any of them are solid, any of them are marked solid, then he's colliding. And so then he's popped to the edge of that. So you take wherever he hit, +1 or you plus or minus it. So then he gets reset. So this should be pretty straightforward. So he's got horizontal sensors. So he looks. So this is X, take 10, and then X plus 10. So he looks forward and back. But he also looks down. Is it? Anyway, there's things you basically look up and down, you look left and right from where he is and try and figure out where to collide with. So it should be pretty easy to like kind of have him up in the air and then drop him down and have him stop and be there. And then we can hopefully press left and right and have him move up the level. So if you look at I haven't got the collision map rendering, but the collision map closely matches these tiles pretty closely. So as you kind of walk, like there, he actually does move down, and then he moves up, and then he moves down, then he moves up. So really, what we should do is be able to drop him from here, have him collide with the ground, and then we should be able to hold right or left, and have him, kind of follow this path. So I think that would be the goal. And here is where you can kind of see actually where you can kind of jump up from below and land on the top. So if you come here and you jump, you shouldn't collide with the bottom here, so you can jump and actually land on the top here. So you won't fall through from the top, you won't just fall through, but you can just come up through it. So there's kind of like a solidity thing where it's not solid from the bottom, but it is solid from the top. So that's another physics thing. So there's some interesting, logic in this. So yeah, so jumping through floors, that's the case where he's jumping through the floor. Okay, so that will be, I think that's the first thing that we need to do, solid tiles. Then there's running. Running actually ties into his, like running and walking actually ties into his animation. His animation has actually got special logic for when he's running or walking. It's that his animation actually plays depending on how fast he's running or how slow he's walking. It's good that someone's done a lot of research into this. There's a lot of research. It's good. So I think this is what we want. I'm actually not sure what's a good data structure for doing this collision checking. It's kind of like some sort of bitmap, like really where it's a bit per cell. Yeah. So we got chunks. Solidity magic happens with the 16 by 16 tiles. So we've got the 8 by 8 tiles, and then this is actually happening at the 16 by 16 tiles. Collision interaction with the solid tiles that make up his basic engine that dictate how he handles floors, walls, ceilings, slopes, and loops. Because this is such a large subject and so complex, this guide more proximate rather than other sonic physics guides, but I've kept speculation to a minimum. Okay. Assuming the ground level to be at Y position, Sonic stands at 20 pixels above ground level. So I think if we rendered I think maybe we're going to have to add the collision map back in as a rendering thing. I took most of that out, but I think I want to be able to render the level collisions again. So we had chunk textures. I think this actually should just probably work. Collision textures. Maybe I should put logic back into the game where you can press C to toggle the collisions like I had before. Actually, especially now since I figured out how to work with transparency in SDL. I think that was a big problem before where I pressed C and I didn't have any transparency, and so all you saw was the collision textures. Okay, so there you go. So you can see this is what Sonic actually should be colliding with. There's actually a couple of layers. There's 2 layers of collision that's going on. But that is what Sonic should be colliding with. So it looks like... so this is the collision textures. So the collision works on the blocks though, doesn't... Oh, sorry, not... you got tiles, blocks, and chunks. And so it works on the block. So I think we need to split each one of these up into blocks when we go to render the collision. So when we go to calculate the collision, we need to split it up into blocks. So even though we're rendering it all together there, I think we only need to look at a couple of blocks when he's moving around. Center line is at his Y position while he's on steep ground. but at Sonic's y plus 8 while he's on flat ground. Okay. Thus, the sensor line should be 20 pixels wide, stretching from Sonic's take temp to plus 10. Anytime detects a solid tile, Sonic should be popped out, set to the edge minus 11, and his ground speed set to 0. He can't be popped out by only 10 because then a point at his x plus 10 would still lie within the edges of the tile. Kitten. I was reading. I think reading that's probably a little bit boring though, actually, because that's X and Y, and well, that's pushing, right? And we don't want pushing just yet. Assuming the ground level to be Y position 736, Sonic stands atop at 716, 20 pixels above ground level. So what I have is, when I run this, you should see the collision textures. I've kind of visually put in pretty close to that. Pretty close to the to that collision pixel there. So I'm actually going to move him up slightly. And then I'm going to move him back. Once I get him to like look pretty much like he's on the once it looks like he's pretty much on that, like touching that collision pixel, or the collision pixels, I'm going to take him back 20 pixels higher. Then I'm going to take off the collision texture and just make sure that it looks right. Just to verify that what this is saying is what I think it's saying. So I thought maybe it was 5 pixels too big, too deep. Yeah, so now he's just maybe 2 pixels too high, maybe. So go back down. So it would be good if I could optimize my chunks. That's actually all in my compression algorithm, which I actually, it used to take 30 seconds to start the game. I optimized it a lot to be able to get it down to, well, I optimized it quite a bit. It didn't take a huge amount of time, it only took a couple hours, but I changed the library a lot to be able to get it down to 1.5 seconds. Okay, so now he's touching pretty much the ground perfectly from what I can see, so I am going to take back 20... Kitten! I'm going to take back 20 pixels. How'd you set me back so far? Oh, jeez. Thank you. 20 pixels high. So hopefully this will be... Actually, and I need to turn off the collision textures now. Okay, and hopefully it looks like Sonic is standing on the ground and that this document is actually what I think it's saying, which is that... No, that's not what he's saying. What is it? 20 pixels above ground level. Assuming the ground level to be a Y position of 736, Sonic stands atop at 716. That's 20 pixels above ground level. That doesn't make sense because I've put him 20 pixels above the collision. I thought, like, because there is a little bit of difference between the collision and the in the actual chunks, there is a slight difference, but it's pretty much exact. So really, I think he should be standing exactly where it collides. I don't know what this is on about. Sonic standing at top at 716, at 20 pixels above ground level. I don't know what that's on about. So I'm gonna probably ignore that for now. I'm going to jumping, switching, full modes. What I want to see is act like the vertical. Oh, okay. Looks like Sonic's got a couple of states. I see. Okay. The 4 modes, let's look at that. Oh, that's when he's running around in a circle, when he's running around loops and that. Anytime Sonic is in the air, he doesn't have to worry about angles or any of that jazz. All he has to do is move using XSP and YSP until he detects the ground, at which point he re-enters the ground state. Okay, so let's say we're going to start off Sonic in... We're actually going to leave Sonic where I put him. He's 20 pixels above ground. What we're going to do is actually put in some logic to start with the physics of Sonic. And he is going to be falling. We're going to have him in the air state. He's 20 pixels above. I'm actually going to start moving the camera down actually, because that's a little bit annoying having to scroll down each time. So the camera is going to... Actually, there is... that's one thing to do. Let's start off with that. There is... camera start positions. So what's that? So that's the start position. So it's a bit weird that when they've disassembled, they've actually extracted out the start positions from the code, but they haven't extracted out the animations. I think that's a bit interesting. But anyway, 2 entries, one corresponding to X and Y locations that you want the player to appear at when the level starts. Okay. That's actually cool, that's good to know. So I'm going to load up those. I'm just going to find the offsets for that. What's the offset? Maybe we should just search it for what it said. We've got bin walk, wasn't it? Whoops, that's not what I want. I want bin walk. I had it running yesterday, I must not save to my shell. So we want to, so bin walk, what we saw yesterday was, was it dash R, bin walk dash R, OX00, 60, stop it. 2 and 8F. Okay, that appears a lot. C1D 0. C1D8, nope. C1E8, nope. C218. I'm just looking like, sometimes they have references to where things should go. Here we go, okay. This is what I should be looking at, s2.txt. Cool, okay, so these are the offsets for Emerald Hill Zone. And that's what I'm going to copy in. So I'm actually going to extend our offsets file to have, so a level offset will have a start pos. So we've got the starting position. Now we need to load it up and then put Sonic at that position. Level blocks, offsets. So we need to slice the, what is it? Level start position of Emerald Zone 1. I'm going to just print it out for now. So I'm going to print out the start position. Is that going to work? Bounded array with byte string. Ah, okay. So it's a byte string. What can I do? Oh, I've got my my word 16s, don't I? So I've got a library that does halves, so I can say collect halves. Yeah. So this is going to so I've got a collect halves function which takes word 8s and converts them into word 16s. No, that's not what I want. So collect halves is a lens from a list to okay, so I need to say unpacked, is it? Unpacked bytes, which is part of data byte string lens. Okay, so I'm going to run this. Actually, I need to. Is that valid lens? It might be valid lens. Let's have a go. So hopefully this will print out two the positions. Like hopefully it'll print out the positions. Actually, I don't even think I need to say taking two, because there's only two in the file, isn't there? Yeah, I think that was a bit silly. I didn't need to do that. That's fine. Hey Thongies, how's it going? Good to see you. Okay, so 655 I actually came up with that myself. So 655 is actually what it's meant to be at. So that's, isn't that? Yeah, that is his position. Cool. So I've got him. I had him at. I did actually have him at pretty close. I positioned him myself, but that's actually funny because it's 96 655, and I actually had it as 660. I think it was. Yeah, 660, 100, and 660. So I was super close to the actual starting position that he's meant to be at. I just kind of put him somewhere that kind of looked roughly right, and I was actually 4 and 5 pixels off each, so that's pretty good. Yep. So we've got this. So what I'm going to do is you definitely know what's going on. I am remaking Sonic the Hedgehog, and I have gotten. Let me show you what I've got real quick. It'll only take me 2 seconds to show you what I got. I'm gonna get rid of that, render that. So this is what I've gotten so far. This is like it loads up the Sonic 2 ROM file, loads up all the art from it, and then renders this. And you can see here, Sonic and Tails. After a second, you can see Sonic gets a bit annoyed that we're not actually playing the game. Tails gets a little bit annoyed too, looks at the screen, and they're doing their wait animations. So that's what we've got so far. So what's going on is I've gotten this, and what I'm doing now is trying to make it so you can actually play the game. And hopefully Sonic will be less annoyed with us. I'm actually going to do... what was the thing that we had? Local. It's not quite local though, is it? Yeah, it's fine. I'll just do it the other way. So this will be game camera. Is what? Oh no, we just said camera now. Setting the camera to the start camera. So we've got word 16, so we need to get C ints. So I'm just going to do from integral on each one and just let it get converted over, and so that should work. Cool. So now if I reload, actually so I'm modifying the camera position, but I actually didn't want to do that. It's not the camera position. Sonic start position. Thank you, Mana Plus, for the follow. Thank you. So this is, I'm putting Sonic actually at his starting position now. Okay, so he is a little bit, like, I think I moved him before that and I said, well, he's 2 pixels high above the collision thing, so... Yeah, so I'm not sure what's going on with that. I mean, maybe his sprite is actually bigger than what this animation frame is showing. Maybe he's actually bigger. Actually, that's something that this doesn't say, is how... So we know... we know how to look out and how to look down, but where do we look down from? Like, how big is Sonic? Like, what pixels do I start kind of seeing he collides with anything? Yeah, that's the interesting thing. Like, when do I actually say that his feet are touching the ground or not? Like, do I measure from? Yeah, like, where do I measure from? Like, 'cause if I have to look 20 pixels down, where do I look from? Yeah, it's not something that's covered here, is it? Maybe if I look at the disassembly, I can figure out some things. Let's Tails do level collision. Sonic do level collision. So go through the primary collision, look at the top solid bit, look at the secondary collision. Yeah, so that's something else I have to figure out. When to use the secondary collision. I think at the moment I can just use the primary one and I'll just have the second one being broken. I think should mostly work, because the collision that I'm rendering looks like it's mostly filled out. There are some things that are missing, but it looks like it's mostly filled out. So if I get the primary collision stuff loading, the game should kind of work, I think. Then it's got a solid bit, getting the x velocity and the y velocity. I'm guessing a0. So we're kind of like using this as a function. So x velocity of a0, I'm guessing a0 is going to be Sonic. So we're saying get the x velocity of Sonic, get the y velocity of Sonic. I think that makes sense. Calculate the angle that he's at. Go back 20. So that's actually hex 20. Go for hex 20 and C0 compare with 40. Okay, I'm not sure what that's doing. But anyway, check if he's hitting the left wall. I'll check if he's hitting the ceiling. Check if he's hitting the right wall. Check the left wall. Where can I check if he's hitting the floor? Isn't it? I mean, that's what it says here. Check Sonic floor. But it looks like, so we do check the left, check the ceiling, check the walls. Oh, okay, there's more here. Okay, check floor. That's what, okay, check floor. Sonic, check floor. Okay. Okay, this is involved. Okay. Subroutine to check if Sonic and Tails is near the floor. Cool. So I mean, we can read this guide, but this guide is confusing me more than probably what this code is actually confusing me. So hopefully between the two I can figure out what's going on. Look at the primary collision. Check that the top solid bit is set. If it is, I'm guessing we're going to move down here. I'm guessing that's what this means. B equal probably, and the plus probably means move down to this label if it is. And I think this is otherwise, so otherwise check the secondary collision, I think it's saying. So basically, you'll check the primary collision if the primary collision bit is check the primary collision, check that it's marked as top solid. If so, do this thing, right? So that says top solid bit, A0. Okay, so check the top solid bit of A0. I thought A0 was Sonic, but that's a little bit confusing. Top solid bit of A0. I'm not sure. Top solid bit A0. Anyway, we'll have to think about that. X position, Y position, Y radius. Okay, so that's the radius to look at, I'm guessing, and the X radius to look at. Primary angle. So I'm guessing it looks at on an angle. Then it goes find floor. Okay, so I think find floor might be what we want. So we've got check floor, now we're going down to find floor, I think. Here we go. Scans this looks exactly like what we want to do first. Cool. Scans vertically for up to 2 16 by 16 blocks to find solid ground or ceiling. Awesome. Solid ground or ceiling. So it checks which one. So I'm guessing if we're going up, it'll check for the ceiling. If we're going down, it'll check for the ground. I'm guessing that's what's happening. So find tile. Do some logic and then either jump to 7F0 or E2. So E2 will either jump to find floor 2. Okay, so I think that is on failure, it will go there. Is that right? Oh no, it looks for the 3FF. I don't know, that must be some sort of flag. I wonder what that is. What that flag is. Does it say here somewhere? No. I'm not sure. But if it goes down to F0, block has some solidity. Pointer to collision data, block ID to collision ID array. Yeah, I mean that's how I'm rendering it. I've got this block ID to collision ID. So I know that I've already handled that, so I can deal with that. Get the collision ID. If the collision ID and with a byte, so get the byte out. I don't know why you have to do that. Oh, that's and word, so it's getting out the lower bits of the collision. It's getting out, I think that's what it's saying. So B, I'm guessing is byte, W is word. I'm just guessing this, so I've never really thought about it before. So move byte, so I think that's move byte, and word, so it's getting at the lower bits, the lower 8 bits of the word. So a word is 16 bits, a byte is 8 bits. So it's getting out the lower 8 bits of this word. If the two things are equal, go down to E3. Oh, sorry, E2, 7E2, which is, I don't know, was that up? That was up, wasn't it? E2, yeah, that was this again. Okay. Not sure what that's about. Collision curve map. I haven't seen that before. Collision curve map. That's interesting. Interesting. I have not seen this collision curve map. That's something to look into. Get angle from the angle map. I have not heard the angle map before. Okay. I'm gonna have to Google that. Well, not Google. I'm gonna have to search for that. Angle map. The angle array. Collision angle array. Curve and resistance mapping. Interesting. I have not seen this. When I looked at this directory, I kind of had a quick look at all the directories, and I noticed collision array, and I noticed all the levels, and just being in the middle of it, I guess I didn't notice that curve and resistance mapping. I don't know what that is. Okay, but anyway, it looks like I'm guessing when it's saying the angle map, I'm guessing that's what it's referring to, this curve and resistance mapping. I'm guessing that's the same thing. So it gets the angle from the angle map, gets the X position, X flipping. I'm guessing that's if we're going up or down. Oh, maybe it's when you're running at a random loop or something that you want to check that you flipped or something when you're upside down because you're running around a loop. It might flip when you're at the top, so that the collision changes. So yeah, it might be that. Actually, but that says X flipping. And Y flipping, X and Y flipping. It might be about that. It might be about when you're going around. That's probably, yeah, get the angle map. It's probably when you're going around a loop. You want to know the angles that you're at. Maybe that's what it's talking about with this, the 4 modes. It's probably what it's talking about when you're in each quadrant. So no, this is quadrant 1, I guess. And then when you're going around, you go on, like this is another quadrant or something. And so, that's probably what this might be about. Get angle from angle map. It's probably calculating this angle that you're running up or down and trying to map it to one of these things. You notice how it's got these things here, FC, F0. This might come from that curve, that angle thing that I'm talking about, that I just found out about. I'm not sure, but maybe. But let's skip that stuff because let's just assume the angle is 0. I'm gonna make the assumption that the floor that we're on is probably no angle. It's not like a pipe or anything, so I'm gonna say that the angle is 0. Okay, so it gets X position, offset in the collision array to look up, so it goes to the collision ray, gets the height from the collision ray. Tests it out. Yeah, so that's the actual test. So it actually tests the bit there, I guess. Okay, so it says it's got a comment here, E2 is when there's no collision. So, yeah, this E2 thing is when it's got no collision. So it looks like a lot of things jump to this E2, but with E2 then does find floor 2. So it like does a second subroutine to try and figure out the floor. Okay. So that's kind of like a fallback, I guess. So we'll try to find some collision, and then it looks like it must fall back to something else. So find floor 2, check 16 by 16 block to find solid ground or ceiling. Isn't that basically what this does? Scans vertically for up to 2 blocks to find ground or ceiling, and this one is checks a block. Ah, I see. Checks a block. I understand. Okay. Okay, so I don't think so why has it got a comment no collision that it goes to E2 and then E2 then checks a block? So this one checks, you know, up to 2 blocks, scans vertically for up to 2 blocks to find a solid ground or ceiling, and then this one checks a single block. From what I can see, it looks like it checks a single block to find a solid ground or ceiling. Interesting. This ring find floor. Rings must have this special finding the floor. Okay. Okay. Pointers to angle buffer. Pointed to angle buffer, right? Yeah. They've all got pointers to angle buffer. So it looks like everything that I'm going to use is going to use the angle buffer in some way to figure out whether it needs to check for a ground or ceiling. Alright, this looks like it's going to be pretty involved. I might have to just play around with it a little bit. Wonder if there's a I guess what would be ideal is like if there was like a really does any maybe a viewer knows, maybe someone's done something to do with a Sega Mega Drive or a Sega Genesis before. Is there an emulator that has like a, I mean, or maybe someone's done something to do with emulation before. I've never really done it, so I don't really know. But is there like are there any emulators out there that have like debuggers or I don't know, something I could step through? Like it'd be cool if I could like put a breakpoint on this fine floor and step through it and see, you know, the state of each one of these and figure out what's going on. That would be really cool. I've never used an emulator that really well, I've never really used an emulator that much to be able to actually go into like debugging a ROM or anything. So it'd be cool if someone knew anything about that. But until then, I guess I'll have a quick Google after this, I guess, and try and figure out if there is a debugger for a Sega Mega Drive. But I think otherwise I'm gonna have to just stare at this for ages and try and figure it out. I don't think it'll be very interesting. Maybe read a little bit about this. I didn't see anything about it checking 2 blocks or anything. So I've got the high mask, that's fine. Oh, okay. Oh. So Sonic's Y position, so his feet, that's why he's got the 20. Assume the ground to be level at Y position of that. Sonic stands atop it at 716. So it looks like, so what I think it's trying to say is that his feet are like 20 pixels high. And so his Y position is actually like, you know, somewhere around his belly, which makes some sense. His Y position is actually meant to be there. And so they check 20 pixels from there to kind of, well, they make him stand 20 pixels up because that's where his feet land. I think that's what it's trying to say. But, I mean, my rendering puts him, like, I actually put him in a position, and then I just render according to what the sprite map says. So, I'm not sure what's going on there. Like, if it says, you know, put 20 pixels between his Y position and where he stands, I think basically where I'm rendering should do that, because the sprite mapping kind of says where to put the tiles. So the sprite mappings actually say, like, you know, put his foot here at plus, you know, minus, probably X position, -5, +3 or something like that, and it would actually put his foot there. and then you've got one here that says like, you know, +5. So then it'll actually be a tile here. So you've got these sprite mappings that actually say where to put them, and I think you can go like to -8 or something, maybe even -10, or there's some sort of limit where they can say like put some pixels but take them back or put them forward. And so you kind of got like an origin, and it renders it according to that origin. So I am rendering Sonic according to an origin. So I've got him like at this position, like I put him at a position, and then I render where he is. And what's actually interesting is that when I run this, it actually looks right. It actually, like the way I'm rendering it actually is right. So I think my origin is right. So I'm not sure what about the 20 pixel stuff. I don't really get that. Because see, look how he's pretty much on the ground. If I, instead of rendering collisions, if I render the actual tiles, he does look like he's perfectly standing on the ground. So, I think my code is right, and I don't understand why it says 20 pixels. I don't get that. But anyway, what I'm trying to look for is blocks. So if you look at Sonic now, it should look like, yeah, he's perfectly standing on the ground. Like that is his actual starting position. That is where he should start. Like that looks right to me. Yeah, it doesn't. I can't see anything about it looking at blocks to figure out collision. I don't. But if I look here, that's definitely what it's meant to be doing. Checks a block to find solid ground or ceiling. And it does have some information about, you know, my collision map that I've got. And from what I can see, it kind of looks like it looks at a block and then looks at the collision map inside of that, like for that block. So I do have like a collision map for that block, but this seems to be looking at two 16 by 16 pixel blocks. And this doesn't seem to mention any of that, I don't think. It does say that it works on the 16 by 16 tiles, but yeah, it doesn't, like, I don't see anything like saying that you need to look at the next two 16 by 16 pixel blocks, so I don't know. This code definitely says that, up to two, I guess it says up to. Oh, but it's scanned vertically for up to, because I mean it tries the first one, if it doesn't find it, then it tries the second one. So like, I feel like, I don't know, I feel like this doesn't go in depth as much as what it should. It's missing some details. So I think I'm gonna have to go away and read this a lot. So I'm sorry. I will probably so I will stream tomorrow as well. So I don't know. I'll have I might have a quick look, and I might have a quick look a little bit after this. I'll have some dinner and have a quick look while I'm eating to try and figure out what's happening here. But I don't know. I might try and find some other documentation other than this one, because this is not being very useful to me at the moment. And I wish that I was really good at reading Motorola assembly, because then I'd be able to figure out this. And I guess what I'll actually look for is a debugger for Sonic, because that'll be super cool, or a debugger for Sega Mega Drive. Okay, so I'm going to find someone to host, and I'm going to start wrapping up. Are there any questions about Haskell or about anything we've done today? 2 a.m. You should be asleep. Oh, I guess it's would it be Sunday over there? Sunday morning? What can we do? What can we do? Sunday morning? Okay, that's not that bad. Get to stay up on weekends. At least I do. I don't know. I guess I might depending on what you do during the day. But yeah, I do get to stay up on weekends, but it's kind of hard for me to. I wake up really early for work, so this person's playing with engine code and doing playing Super Metroid, which hopefully those are related. If it's engine code and Super Metroid, it's similar to what I'm doing, but maybe those are not related. I'm not sure. Anyway, we're gonna give it a go. We'll host this person, say hi to them. Hopefully they're doing something like what I've been doing, so everyone's interested. But we'll see. Did I catch Komet's stream last week? I did. He is also going to be streaming in the morning. I don't know if I'll be up for it, but I'm going to try and wake up as early as I can to try and catch his stream. For me, it's like 3 o'clock in the morning until 6 that he streams. No, 2 o'clock in the morning until 6 that he streams. So I probably won't catch the beginning of it, but I'll try and catch the end of it. I do usually start work at around 5 or somewhere between 5 and 6. So I will wake up for the end of it and I'll stream straight after him. We'll tag team it. Cool. So hopefully you'll be watching his stream as well, and at least I'll make sure that I catch the ending of his stream at least. So I'll be up for that. Cool. And hopefully we can talk then. And then I'll be streaming anyway, so we can talk then anyway, if you're around. Okay. Let's host this person. Hopefully they're doing something related to what I'm doing, so that everyone is kind of interested. It looks like they are not writing Haskell from that screenshot. It does not look like Haskell to me, but maybe we can convince them to start writing Metroid in Haskell. Okay, so thanks for tuning in. I'll catch you tomorrow. I'll stream early in the morning, straight after Komet. Make sure you watch Komet because he's awesome, and I'll see you then. Cool. Thanks for watching, everyone.